In this video, we're still going to be solving our quadratics, particularly when b is equal to 0. So we're mixing that x term. But we're going to focus now on solving by factoring. So just remember, again, whenever you're solving but focusing on factoring, we need to make sure that our equation is equal to 0, right? So make sure your equation is equal to 0 because our y is equal to 0 when solving for x, as well as make sure that first step is that we're always looking for that GCF. So keep in mind whenever you're factoring that we have those two things here. So like in example 1, our equation is equal to 0. So we're good on that part. Do we have a GCF? Yes. Notice how I can divide both terms by 3. So we're going to take out our GCF here, and we're left with now, well, 3 divided by 3 is just 1, so x squared, then minus 16 from 48 divided by 3 is equal to 0. Now notice inside of the parentheses, we have our difference of squares, right? Because what is the square root of 16? 4. So now I've got here 3 times x plus 4 times x minus 4 is equal to 0. Now we can go through and solve for x. Then if you recall, if I have 3 all by itself, will 3 ever equal 0? No. So that constant here, that value just goes away. Then we've got, of course, our x plus 4 is equal to 0, and x minus 4 is equal to 0. So notice how we still get x is equal to positive and negative 4. Because here we would, in the first equation, right, subtract 4 to solve for x. There's your negative 4. Here I would add 4 to both sides of the equation to solve for x. And there's your positive 4. So that's why here you get positive and negative 4 as your answer. So let's look at example 2. Is our equation equal to 0? No. So what do we need to do first to get our quadratic equal to 0? Subtract 164. So we're going to subtract 164 here from both sides. So now I've got 2x squared minus 162, because they're like terms here, is equal to 0. Now, do we have a common factor? Yes. I can divide both of these by 2. When we take out our GCF here, our greatest common factor of 2, we're left with x squared, right? Because 2 divided by 2 is 1. Then minus, I'm sorry, not 64. What am I writing here? You get 81 is equal to 0. Then notice inside of our parentheses, do we have a difference of 2 squares? Yes, because the square root of 81 is 9. And then I forgot to mention in this first one here, but we also have the square root of x squared, right? Because these are inverse operations, you're just left with the square root of x squared is just x. So now I've got here 2 times x plus 9 times x minus 9 is equal to 0. And then I solve for x. Notice how, again, we just have 2. Will 2 ever equal 0? No. So 2 is not a solution because it just cancels out, right? 2 is never equal to 0. But we are left with x plus 9 is equal to 0, and x minus 9 is equal to 0. So notice how from our two equations here when solving for x, x is equal to positive and negative 9. So go ahead now, pause the video here. We have our U try. Go ahead and pause the video here, solve this one, and then let's see what you get. Now let's take a look at that U try. Is our quadratic equal to 0? Yes. Do we have a GCF, a common factor? Yes. You can divide both of these, sorry guys, you can divide both of these by 2. So now I've got 2 and then times x squared minus 36 is equal to 0. Then you should have noticed we do have a difference of 2 perfect squares. because we have x squared, the square root of x squared is just x, and then the square root of 36 is 6. So we do have the difference of two perfect squares here. So now I've got 2 times x plus 6 times x minus 6 is equal to 0. Then notice 2 will just cancel out, right? Because 2 cannot equal 0. You should have gotten x is equal to positive and negative 6. Now let's take a look at these last two problems and then we'll discuss, right? What do you notice? Well, in A, are these two perfect squares? Absolutely, if I wanted to factor that, right? I've got the square root of x squared. If I have my inverse operations, we're just left with x. Then I know that the square root of 9 is also 3. However, is it a difference of two squares? No. Notice how we have the sum of two squares. So this is a sum of two perfect squares. So how would we factor this? Well, maybe we could say it's x plus 3 times x plus 3. But if I were to multiply this out, right, let's say I'll use the box method, and I have my x plus 3 times x plus 3. That's x squared, right? I've got 3x here, and positive 9. But notice what happens. Did the 3x's cancel out? No. I actually have 3x plus 3x, which is 6x. But we don't have 6x. So it's not going to be x plus 3 times x plus 3. So what if maybe it was x minus 3, right? So x minus 3 times x minus 3, because when multiplying two negatives would make my positive 9, right? So if I were to multiply that out, x and negative 3, x and negative 3, so x squared, negative 3x here, and there's my positive 9. But again, notice how on the diagonal, do the negative 3x's cancel each other out? No, because negative 3 plus negative 3 is now negative 6x. So that now is going, we're now thinking, okay, so how are we supposed to factor then the sum of two perfect squares if basically we can't factor it, right? So I'm going to go back to A and let's take a look at B. What I want you to do is go ahead and pause the video, solve B like it's a square root method, all right? So go ahead, pause the video, solve for X, and then we'll talk about what you notice. So when solving this second equation, if I wanted to do square root method, so we'll treat it like it's a two-step, right? I'm going to subtract the 252 from both sides of my equation. Now I've got 7x squared is equal to negative 252. We're still multiplying that x term by 7, so now we're going to divide by 7. And I've got x squared is equal to negative 36. Then, of course, that last step, right, because we have x squared, the inverse square root. And these cancel out, right, because they're inverse operations. And x is equal to the square root of a negative 36. So let's say you put that in the calculator. You get an error message, right? Well, if you think about it, can we take the square root of a negative number? Is there a square root of that negative? Well, no, because the square root of 36, right, is positive 6 and negative 6, because 6 times 6 is 36, and negative 6 times negative 6 is 36, right? Because we're multiplying the values to themselves. But can you multiply anything by itself or to itself that would get you a negative 36? No. So here, basically, if you think about it, right? If I have the square root of negative 36, if I were to break this apart into two radicals, this is the same as the square root of 36 times the square root of negative 1. Well, okay, we just said, right? The square root of 36 is positive and negative 6, right? So then what is the square root of negative 1? So this is now our new concept that we're going to focus more on. But the square root of negative 1 is going to represent our imaginary number. So in this case, we are going to use I. So the square root of negative 36 is positive negative 6i. because of the square root of -1. And we're going to focus more on that and understanding that imaginary number. So then going back here to A, that means how am I going to factor this? This case now means I'm not going to have just x plus 3 times x minus 3, right? Because that would represent x squared minus 9. This now means when we're factoring the sum of two squares, we are now going to have x plus 3i times x minus 3i. And again, when we understand here with our I, we'll focus on how this comes to x plus 3i times x minus 3i.